Okay, so when we translate, every point goes the same distance, the same direction. So if A goes 4 back and 6 down, 4 back and 6 down, B will go 4 back and 6 down, and C will go 4 back and 6 down. That's what a translation is. Every point moves the same direction and the same distance. So, it says, translate this graph 7, -4. The first number is going to be your x, how far you move in the x direction. Your second number is how far you're going to move in the y direction. So you're going to translate it 7 to the right and 4 down. So E, 7 to the right, 1, 2, 3, 4, 5, 6, 7 to the right, and 4 down. 1, 2, 3, 4 down. Here's where E prime is. F, 7 to the right, 1, 2, 3, 4, 5, 6, 7, and 4 down. 1, 2, 3, 4. F prime. G, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. G prime. All right. So, if you look at the points, E was at, -5, 4. F was at -1, 5. And G was at -2, -1. What really we did is we added 7 to each number. So E prime was 7 to the x, which is 2, and -4 to the y, 0. F, add 7. Well, -1 plus 7 is 6. 5 minus 4 is 1. And G, 7 plus -2 is 5. -4 plus -1 is -5. And those are all the points where they're at. Okay? So you just take what you're doing to it, and you can add or subtract them to the ordered pairs to get them, or you can just count when the graph to get them. Okay? All right, what happened here? What is our translation here? Well, you only need to do it for 1 point. Only need to figure it out for 1 point. So let's do it for S to S prime. How far did it move? Well, it moved 1 to the left. 1 to the left is positive or negative. So it's a -1, and it moved 1, 2, 3, 4 down. So it's a -4. Every point moved 1 to the left and 4 down. The translation is -1, -4. What's the translation rule that maps C to A? Well, C is here, A is here. What's C to A? What's your translation rule, Mr. Meyer? Yep, and Y would be 2. What would map B to D? What would map B to D? How would you map that one, Cole Klingbeil? -1, 2. How about G to H? How would you map G to H in this situation? Albert. Not 1, 2. Got to do X first. How far do we move in the X direction? 2, 2, 1. Okay? Got to be careful there. All right. Next vocab word. Composition of rigid motions is a transformation with 2 or more rigid motions and which the second rigid motion is performed on the image of the first rigid motion. So a long, complicated definition. I will make it easier when I explain it. Hi, Nikita. Doctor appointment? Dentist. So, when we do a composition of rigid motions, we're going to do the one on the right first and then the one on the left. So the order that we do them is this one first, then we do this one. So in this case, we would translate 2 to the left and 5 up, then we'd reflect across the line L. Okay? That's how we would do that. We have to do this first, then we do this second in a composition of transformations. Now, when it's translation, it doesn't get too complicated. So here's a translation. So when we write it with a composition of transformations, a mover wants to move a box from A to B, and then he moves it from B to C. Okay? So if he moves it from A to B, he's going to translate it 1 to the left and 2 down. -1, -2. Then when he translates it from B to C, he's going to translate it -3, 3 to the left, and 4 up. Okay? 3 to the left and 4 up. So when you write the composition of transformations, this is first, this is second. So you're first going to go 1 back, 2 down, then you're going to go 3 back, 4 up. Okay? So, crazy new dance steps. Okay? What's the transformation, composition of transformations that maps A to B to C? A to B to C. Okay? First, A to B. That's a translation of what? What? What, Quinn? 2, 2. Okay? And then from B to C, what's that translation? What's that translation, Justin? Yeah? No. A went 2 over, 2 up, so B goes how far over? 1, and how far down? 1. So it's 1, -1. 1, -1. Okay, so if we would add these together, what's the final translation that actually occurs if we add these together? Well, what's 1 plus 2? 3. What's -1 plus 2? 1. So in the end, really, they went 3 over and 1 up. Okay? So when you have a composition of transformations, you can just add them to get the final result. But if they want them as a composition of transformations, you write them separately. Now, if we would end just right here, today would it be easy? Okay? But of course, we can't just end here and make things just totally easy. We have to add in this. And what this is what they're saying here is any translation can be a combination of the first thing we learned the other day. So what we learned first the other day was a reflection. So any translation can be the combination of 2 reflections, across a line and then across the line again. So we take this, and like this. Okay? So The distance between the translations, between the A's, and the distance between the lines of reflection is half. So this distance here is half the distance from A to A, or the distance from A to A is twice the distance of your lines of reflection. Now, am I going to test you over that? Not really. I want you to know translations, but you might see a problem on today's homework dealing with the lines of reflection. So a translation is really a double reflection, but the easier way to think of a translation is a slide. You're going to slide every point the same amount in the same direction. The same amount in the same direction. Okay, so your first assignment's out there. Probably your second assignment's out there too, but let's just work on the first assignment.